Okay, so um, hello everyone. So myself Satya Prakash Yadav. People are still joining, so I will wait for some few 1 or 2 minutes. Okay, so let me start. So 1 minute. People are still joining, so I will just change the setting. Okay, I think I will start now. So so, so one more person has request to join. Okay, so let me start. So, myself Satya Prakash Yadav. People are still joining. I don't know. I will change the setting. Okay, so myself Satya Prakash Yadav. So I am a PMRF. People are still joining. I am getting message. I will wait for 1 or 2 minutes more. Okay, so now let me start. So first of all, welcome to the like problem solving session on analytical chemistry. So the course ID is CY61 and instructor is Professor Devashish Ray from IIT Kharagpur. So myself Satya Prakash Yadav. I'm a PMRF scholar from August 2020 to present, and I'm a PhD student under Professor Satish Patil, Solid State in Structural Chemistry Unit, Indian Institute of Science. So I will go to the presentation mode. So we will admit all. Okay. So I will switch off my video now. Camera. Okay. So so this is the 12-week course in which in a week one you will basically learn about the chemical and material analysis methods. In week two we will go through the what is the role of the analytical chemistry and techniques. In week third basically we will go through the chemical equilibrium and basis of the chemical analysis. Week 4 and 5 we will go to the spectroscopic method where we will discuss the uh, interaction of light and matter. And then in week 6 and 7, we are going to discuss about the thermal methods, basically TGA and DSC. And week 8 and 9 we are going to see the electrochemical methods. Week 10 we will read about the electrochemical sensors. In 11 we will see the bioanalytical chemistry. And week 12 we will basically go through the what is the application of the chemical analysis. So before so in week 1 basically you have gone through the 5 lectures. So in the first lectures we have seen the like what is the need of the analytical chemistry, and in the subsequent lecture week 2, week 3, week 4 and week 5 we have seen the methods to analyze the material in the solution. I will just check once again. If anyone is still waiting, I will just join them. Okay. So basically I am going to solve the assignments of the previous year. So the role of the PMRF is that like we have to solve the previous year question uh, assignments. In that the 10 questions are there. I will go through one by one, and with how to tackle those problems, how to like critically think about the problem, we have to go through. So the first question is, in which method we explore the interaction between electromagnetic radiation and analyte atom or molecules or emission of the radiation by analyte. So first is the gravimetric analysis. So what is the gravimetric analysis? So basically here we determine the mass of the analyte or some compound chemically related to it. So here what we do basically, if we want to like analyze some compound, so we measure the mass of the compound, or we just convert into some chemical form, and that measurement is where we will measure the compound weight and find out the what is the analyte quantity. What is the volumetric method? Here what we measure? We measure the volume of titrate. So titrate. Basically, we measure here the volume of the titrate. So I will show you. So okay. So the in a analytical electroanalytical method. So what we measure here, we see the potential uh, and current and resistance and quantity of charge passed, basically Q. And spectroscopic method is what? Here we basically deal with the interaction of light and matter. Okay, so the answer is, in which method we explore the interaction between electromagnetic radiation and analyte atom or molecule or emission of the radiation by analyte. So basically your answer is D. So first thing is that in the gravimetric method we will go through in the upcoming lectures. Volumetric method we will go to the week 2, and electroanalytical method where I already told you it is in the week 8 and 9, and spectroscopic method we will go in detail in the week 4 and 5. So coming to the question number 2. So here the question is, during qualitative quantitative analysis of a sample in volumetric method, titration is done by apparatus. So first I will show you the what is the titration. So here basically what we do, so there are two things. One is the analyte and other is the titrate, right? So titrate we take in the burette and analyte we take the known volume of the analyte through a pipette in a conical flask. Then we start doing the titration. We mark the initial reading and the final reading. So whatever volume is consumed is correspond to the equivalent to the what is the analyte present in the uh, analyte present in the like titration conical flask. So by this way we can find out the what is the quantity of the sample in the analyte. So here what is the most important thing? So one is that pipette where we with through which we take the known amount of the analyte which need to be find out, and other is the burette where we take the initial and final reading. So if we see the option A is volumetric flask and crucible, that is wrong. Burette and pipette basically, yeah, here uh, uh, burette is necessary for the titrate and pipette is for the analyte. In the C, that conical flask and funnel, so that is the uh, that is just for the helping purpose, like we used to store the analyte in conical, and funnel we just used to transfer the titrate in the burette. So that is also not, and RB and funnel, this is the complete. So the answer is burette and pipette. If I go to the question number 3, so the question is the process in which the water and volatile are evaporized and organic substance are burned in the presence of oxygen in air to CO2 and oxide of N2, and most minerals are converted to oxides, sulfate, phosphate, chloride, and silicate is known as. So first of all, um, we have to know what are the each term. So what is the weight acing? So weight acing is basically we take the organic substance, we add the oxidizing agent like nitric acid, hydrogen peroxide, like that, and convert it to the do the oxidation of the organic substance. That is the weight acing, because here we need the solution. That's why it's a weight acing. Second is the dry acing. So dry acing is what? Basically here we take the substance, organic substance, we heat in the muffle furnace. So the question is, what is the muffle furnace? Muffle furnace. So the muffle furnace is basically uh, we had a setup where we can go very high temperature, like close to 800 centigrade, from some 25 degree, that normal, to 800 centigrade. So what we do here, and in presence of air, so what we do here, so once that organic substance is heated at very high temperature under air, what will happen? So the organic substance here, this thermal decomposition will happen. So thermal decomposition will happen. So the thermal decomposition. So basically our organic substance has C, carbon, hydrogen, nitrogen, and oxygen. So what will happen? Basically it will go to the carbon dioxide, hydrogen will go to the water, nitrogen will evolve as a N2 because we are completely decomposing this, and oxygen is in form of like CO2 and H2. So what happens here? This organic substance will thermally decompose and go to the, like carbon will go to the carbon dioxide, hydrogen will go to the H2, and nitrogen will go to the N2. Another thing, like when we hit the most mineral like ore, kind of ore, like ore, if we heat, so what will happen? So basically that thermal decomposition will happen. Thermal decomposition will happen and it will form the stable. So basically their oxide, sulfate, phosphate, chloride and silicate, which are stable at high temperature, that compound will form. The answer is that dry acid. If we go to the question number 4, so here question is, which instrument is used for the elemental analysis for sample that is coupled with three of the following instrument technique? That is the Rutherford back scattering, proton emission and X-ray fluorescence. Okay, so if we answer this question, if we go back to the literature, so basically July 97, this US has sent that one pathfinder spacecraft to the Mars surface, and this find out what are the content like rock and swell. So in this they send the instrument called APXS. Okay, so here A is the alpha, P is the stand for the proton, X stand for the X-ray, and S is of course, like as usual, this is the spectroscopy. So here, so alpha, proton, X-ray, spectroscopy. So what are the rules? So basically alpha will hit the nuclei of light element, and this will emit the proton. So basically we can say that it's a proton emission spectroscopy. And other thing, so here what are the light element? Basically you have sodium, magnesium, aluminum, silicon and sulfur. So that is the first process. What is the second process will happen? This will also do, second process will happen as a Rutherford backscattering. Here what are the element we can find out? That is carbon and oxygen. The third process which involved with the X-ray fluorescence. So through this here, this from sodium to iron we can find out. So by the alpha proton X-ray spectroscopy we can find out all the element. So here this spacecraft is sent for the elemental analysis. So from here we can find out all the element from like basically whatever the carbon, oxygen, sodium, magnesium, aluminum, silicon and sulfur, and through the X-ray we can find out the sodium and iron. So this is the alpha proton X-ray spectroscopy. So EPR is the like electromagnetic electron paramagnetic resonance. So here basically we have to have the like unpaired electron. So basically to detect this we use the EPR, And FTIR, here we basically give the IR radiation to the sample and we measure the transmittance versus wave number in the same IR. So the answer is the EPX spectroscopy, where all the three processes is involved. One is the Rutherford backscattering, through which we determine the carbon and oxygen. Other is the proton emission, because alpha will interact with the nuclei of the light element, through which we determine the sodium, magnesium, aluminum, silicon, and sulfur. And third process is the X-ray fluorescence. This X, which which helps to determine the sodium to iron. Now the question is, fifth question is the choose the correct option given below for the absorption spectroscopy. So the absorption spectroscopy, we have to know the what is the Beer-Lambert law. So this is the very important law where, 1 minute, okay. So absorption is proportional to the concentration of the analyte, and other is the L, that is the path length of the path length. So, and if we write the full expression, basically epsilon CL. This is the Beer-Lambert law. So epsilon is the molar absorptivity. So here if we read, the absorption is inversely proportional to the color intensity. Absorption is the inversely proportional to the concentration of the species responsible for the color. No. So because we have more analyte, the absorption will be more. Absorption is the directly proportional to the concentration of the species responsible to the for the color. That is correct. Absorption remain constant with the concentration of the color species. No. So basically here what we have, one I0, this is your sample holder and this is the I. So this absorption, this is log I by I0 is epsilon. So the answer is absorption is directly proportional to the concentration of a species responsible for the color. Now, during the analysis of the kidney sample, when SnCl2 and HCl was added, arsenic present in the solution was reduced to. So before going to these questions 6, 7 and 8, 9, so I will discuss uh, this this tear kidney issue. So basically the problem is, okay, this 1 minute. So basically what happens, dear death story I will discuss here. Okay, 1 minute, some people are still waiting. So what happens in Kentucky, USA. So this deer, white deer, is basically died. Okay, so the investigator want to know what is the reason behind this white deer are died. So investigator noticed that this grass was surrounded nearly nearby power line pole was uh, wilted and discovered. They speculate that herbicide, that sorry, herbicide, herbicide might be the culprit, because of which that deers are dying. So first is, what is the herbicide they are using? That time is CH3 ASOOS2 derivative. So the disodium salt of this herbicide people are using. This is CH3 ASOONA. So here basically I will like the reason is the arsenic poisoning, that I will discuss one by one. So what they did, they they took the kidney tissue, kidney tissue of this dead deer. Now this tissue, what in all it have? It has this herbicide plus tissue. Tissue is basically your organic substance. Organic substance. Now the question is that how to get rid of this tissue. So we refer to the previous question, how to decompose the organic substance. So the answer is dry acid. Dry acid. So what happens if we do the dry acid of this kidney tissue of the dead deer? So here we do basically we heat at 555 degree for 2 hours. Okay, so what happens here? So basically your organic substance, whatever it is, it will evaporate, like CO2 gas will be evolved, hydrogen will be evolved, and water will form. So here the tissue. Now what will happen once we heat this herbicide? Okay, so what will happen? So we refer to again to the previous question. What will happen once we heat that mineral? Basically, it will form the oxide of oxide of oxide of arsenic. Now arsenic is stable in arsenic 3 plus, arsenic 5 plus. So now which oxide will form? Because here we have the excess of oxygen. So the stable As2O5 compound will form. Uh, that is the oxide which form. Now once they want to analyze that what is the reason behind this issue. So now As25, what we can do, now we want to dissolve this, because as AS2O3 we cannot do the analysis. So what we have to use some dissolution method. So now we know that once we have the oxide, like your iron oxide or Fe3O4 or manganese oxide or NiO like etc. What is the method to dissolve this? Basically, we use the mineral acid here. Mineral acid. So here, once we add in that mineral acid, basically what it will give? It will give the corresponding ion like Fe3 plus, Mn4 plus, like that, plus that corresponding water. So once we dissolve this As2O5 in the HCl, what will happen? It will form H3ASO4. O4. Right? Now we wanted to reduce it. So what will happen? So how we can reduce it? So basically we use the mild reducing agent, that is called SnCl2 plus HCl. What will happen here? It will reduce to H3AsO3 plus that corresponding oxidation will happen. This is for SnCl4. The in the first zero assignment you have seen that reducing agent will reduce other and oxidize itself in water molecule. Now the question is, what will happen to this H3AsO3? That if we add the zinc H3AsO3, once we put this zinc plus 6HCl, what will form? Basically, it will form a arsine gas AsH3, which is very poisonous gas plus 3 water molecule. So what will happen? It will oxidize itself. It reduce to arsine gas. So there is a there is a special setup. So here what we do, basically this is very poisonous gas. So what we do here, we take the reaction mixture, we put first SnCl2 and HCl, arsine gas will evolve. We have to put in the solution so that that gas bubble will form. Now if we want to stabilize this arsine gas, basically we use the silver, this is diethyl diethyl dithio, because there is two sulfur carbamate. So this is the chelating complex. So here this arsine, basically it will form a like a stable complex and 6 Ag, basically it will reduce to Ag and 3H plus. So in the reaction mixture we are putting SnCl2 in HCl, so it will form H3AsO3. Now we will put the zinc, then the arsine gas will evolve and we have to put in the some solution which can stabilize this arsine. Now what will happen? This is the colored complex. Now we know that colored complex we can do the spectroscopic method, which is basically we do the UV visible absorption spectroscopy. So the color compound have some like absorption wavelength, that is called lambda max. So basically with the lambda max we can find out that what is the concentration of this. So basically suppose we will plot first A versus C. So once your concentration will increase, etc. Now we will take, so we have find out some we have taken some 5 different known concentration and we plot one absorption versus concentration. Now if we want to know the unknown, we will record the UV visible absorption of the unknown sample. So suppose it has come somewhere here. This is for the unknown. Now we will go back to like reverse and calculate. Now we know the absorption here, and then absorption is equal to epsilon BC, and we can calculate because we know that we know the path length, we know the absorptivity, we know the absorption, so we can find out what is the concentration of the this arch, like this complex is available. Then we can go back, go back to the reverse calculation and find out how much this herbicide is there, which is the responsible for the uh, like death of the deer. So the question is, now we will go to the question one by one. So during the analysis of the deer kidney sample, when SnCl2 and HCl was treated, arsenic present in the solution was reduced. So we have read this, once we use the SnCl2 and HCl, it will form this H3AsO4 will go back to the H3AsO3. The option is the C. That this is wrong. H3AS4 will go to the H3. This is also wrong. H3ASO3 to H3ASO4. That is also wrong. So basically here oxidation is happening. In the question it is reduction. So the next question, in the qualitative analysis of the arsenic containing deer kidney sample, H3ASO3 was converted to AS3 by adding. So we know that arsenic gas can be produced by adding the zinc and HCl. So we have the answer here. This SnCl2 and HCl, no. SnCl2 HCl, no. ZnCl2 and HCl, no, because this is the farm product. So I can write out the once more this H3ASO3 plus zinc plus HCl. What will happen? It will form AsH3 plus ZnCl2 plus water. Now we want to balance it. So basically 3 water molecule will come out. So here we need 6. Now we have 6 Cl2. So now here we have to give 3. Now we have to give 3 zinc. So by this way we can like do the stoichiometry. Now, so what is the name of the herbicide found in the deer kidney sample? So we have already seen that this is the sodium arsenite. Incorrect, because it is asking the herbicide. Monosodium salt of the methane arsenate. Wrong. Tetrasodium, because here we can't accommodate 4 sodium. Right. Here H will reduce by sodium, so it will form a disodium CH3AS ONA twice. So we can see that maximum 2 sodium ion it can. So this is the disodium salt of the methyl arsenic acid. So after carrying out dry acing process in deer kidney sample, primarily arsenic was converted into. So after carrying out the dry acing process in deer kidney sample, primarily arsenic was converted into. Now what we have here, we had that arsenic herbicide plus this tissue of the kidney. So I told you, once we do the dry acing, what happens here? So we do this. So this is the organic substance. Once we heat it, what will happen? Organic substance will convert into CO2, water, nitrogen, like that. And what happens to the arsenic herbicide? So it will go to the stable oxide formation will happen on the dry acing, because oxide are stable at higher temperature. So what are the possibility? I told you AS3 plus AS5 plus, because here we have the excess of oxygen, so the higher oxidation AS2O5 will form. So AS2O5 will form. Now the asking is the what is the oxidation state. So now we know that in the oxides, oxygen oxidation state is -2. So now we can suppose we let arsenic oxidation state is X. So now X2 into X plus 5 into -2 is equal to 0, because the charge on the compound is 0. So from here we can find out 2x is equal to 10, x is equal to plus 5. So what is the arsenic oxidation state is plus 5. So the answer is the D. AS2O5 in its oxidation state is plus 5. So this is the last question. During the analysis of the nickel 2 plus sample, electrical property such as current, potential, resistance and coulomb counted by the method. So I already told, in gravimetry what we measure? Basically we measure the mass of the analyte, analyte, analyte or compound related, basically which is chemically related to it. So that is wrong. Sorry, that is wrong. Calorimetry method. Calorimetry method. Basically, here we measure the heat. In the electroanalytical method, basically we are going to discuss in week 8 and 9. So here we measure the current I, potential V, resistance R, and charge Q. So that is the answer. In APX, I already told like that APX is alpha, P means proton, and X is the X-ray spectrometer. So alpha proton X-ray spectrometer is the full form of this APX. So this is the answer of this. Now, so thank you. I will keep it. Now I will come back to it. Okay. Oh, sorry, because I haven't shared the PPT. Okay, okay. Sorry. Okay, I will. Should I go through once? Will it be fine? Hello. Okay, okay. Thank you. I will go through once again. Sorry, actually I forgot to share the presentation. Not an issue. I will go through once again and try to go through once. Quickly I will go through once again. So here basically it's a 12-week course where we will in week 1 we basically be uh, go through the chemical and material analysis method. In week 2 we will have to the role of the analytical chemistry and techniques. Week 3 we have the chemical equilibria and basics of the chemical analysis. Week 4 and 5 we will go through the spectroscopic method like UV visible fluorescence and all. So in week 6 and 7 we go through the thermal methods, basically TJ and DAC. And week 8 and 9 we will go to the electroanalytical methods. And week 10 we have electrochemical sensor. Week 11 we have bioanalytical chemistry. And week 12 we have the what are the application of the chemical analysis. So in first it says that in this method we have explored the interaction between electromagnetic radiation and analyte of atoms or molecule or emission of the analyte. So we know that in the gravimetric analysis we determine the mass of the analyte or some compound chemically related to it. So this is the gravimetric. In the volumetric method, what we measure? Basically, we measure the volume of the titrant. And in electroanalytical method, we measure the potential, current, resistance, and quantity of the charge passed. This is Q. In spectroscopic method, basically here we deal with the interaction of light and matter. So the what is the answer of this? This is the spectroscopic method. So 1 minute. Can everyone got the first answer? Like answer for the first question? Anyone can just write yes. Hello. Yeah. Thank you. Thank you. Thank you. I will go to the next question then. Huh. Next question is that during qualitative analysis of a sample in volumetric method, titration is done by the apparatus. So I will go through the go through the what is the volumetric method in volumetric method titration. So what we have here, we have the one is the analyte and other is the titrate. So basically we take the analyte through a pipette. So through a pipette we take a like known volume of the analyte into the conical flask. Now we titrate with the titrate and we mark the initial and final reading of this titrate. So we know that what is the volume of titrate consumed for the particular analyte. Then what happens? Like we can calculate what is the amount of the analyte present in the uh, conical flask. So here, so if we want to know what are the main two things which is required for the volumetric analysis. One is the pipette, which is required to take the known amount of the analyte, and other thing is that burette, which helps to find out the initial and final reading of the this titrate, through which we can uh, uh, calculate the amount of the analyte present in the solution. So can anyone guess now what is the answer? Oh, next question you can't see. Okay. Okay. Can you can you see the next question now? Hello. Okay. Okay. Fine. Fine. Okay. So just wanted to confirm once again. Can you see now? No. Okay, because I have changed this one. Okay. I think I will join with another account so that I can monitor both together. 1 minute. Okay. One more thing I can do. I can share the screen. It will be better. I think now you can see, right? 1 minute. Now can you see the a window where that Google Meet is there? Alright. Okay, I think now you can see that. Okay, that's okay. So this. Wait, hmm, okay. So that's the second question is done. Will it fine or I will once again I should go through that second question. Anyone can just confirm. Hello. Okay, that's great. Now I will go to the third question. Okay. So here the process in which water and volatiles are evaporated and organic substance are burned in presence of oxygen in air to CO2 and oxides of N2 and most minerals are converted to oxide, sulfate, phosphate, chloride and silicates. So basically what is the weight AC? So basically here what we take the organic substance and we put the oxidizing agents such as NH3 and H2O2 to oxidize that organic substance. Because here we use the solution, that's why it's a wet acid. What is the dry acid? Basically here we put the organic substance in the muffle furnace. We put the muffle furnace and we heat at a very high temperature, like 600 to 800 degrees centigrade in the air. So what will happen? Basically, the thermal decomposition of the this organic substance will happen. So in the thermal decomposition, what will happen? This carbon go to the carbon dioxide, hydrogen will go to the H2O, and nitrogen is evaporate at the N2. So that is the first thing. Organic substance are born in the presence of oxygen in air to CO2 and water and oxides of it. Second thing is what will happen to the ores, like suppose these minerals. Once we heat it, it will thermally decompose and it will form the stable oxides and sulfates or phosphate, chloride and silicate, which are stable at very high temperature. So the answer of this question is the dry acid. That everyone got it? This question process. Anyone can reply. That question third is done. Are any doubt in the question number third? Okay, that's great. Moving to the next question. Which instrument is used for the elemental analysis of a sample that is coupled with three of the following instrument technique? That is the Rutherford back scattering spectroscopy, proton emission spectroscopy, and X-ray fluorescence. So this question is related to in July 1997, USA has sent a Pathfinder spacecraft in the Mars to to do the elemental analysis of the Mars surface. So basically, their rocks and soils are there. So this APX spectrometer has said. So the S is stand for the spectroscopy, X is stand for the X-ray, P is stand for the proton and A is stand for the alpha. So now what are the things, what are the processes happen? So alpha will interact with the nuclei of light element like sodium, magnesium, aluminum, silicon and sulfur. And it will emit the proton. It will emit the proton. So basically here, this is the proton emission spectroscopy is to help to find out this to do the elemental analysis of the sodium, magnesium, aluminum, and silicon and sulfur. Right. The other thing is that alpha will do the Rutherford backscattering with carbon and oxygen. Right. So the Rutherford backscattering will help to do the elemental analysis of carbon and oxygen. And that X-ray fluorescence, that X is stand for X-ray fluorescence, will helps to analyze the sodium to iron element. So basically this APX spectroscopy is involved the all the three elements of the Rutherford backscattering spectroscopy, proton emission spectroscopy, and X-ray fluorescence. So basically you can see that P for proton, X-ray, X for X-ray, like that. So EPR is basically where the unpaired electron is there. So that to find out the which compound has unpaired electron, basically we use the EPR spectroscopy. In the FTIR, what we basically do, we put the IR radiation and measure the transmittance versus wave number. So we find out the what are the like corresponding to wave number, what is the transmittance, and this several organic compound, they're like carbonyl, alkene, they have characteristic absorption across the particular wave number. So we can find out the what are the functional group and present in the compound. So that question number 4 is clear. Can anyone reply? Anyone? Okay. Question number 5, the choose the correct option given below for the absorption spectroscopy. So once that we think about the absorption spectroscopy, the first thing came in the mind is the Beer-Lambert law. So what is the Beer-Lambert law? Beer-Lambert law says that the absorption is proportional to the concentration of the analyte and the path length of the solution. Basically, we put in the cubit. So this is the path length called B or L according to the repetition. So here we have the intensity of the light, which is I0. Once it's passed through the solution, the intensity of the transmitted light is I. So basically, the absorption is log I by I0, which is epsilon CL. So it is proportional to the concentration of analyte and path length of the this solution, which in which the like cubit, which in which the solution is kept, and epsilon is the molar absorptive, which is the constant. So now if we see that which is the correct absorption is inversely proportional to the color intensity, wrong, because we can see that here absorption is inversely proportional to the concentration of the species responsible for the color. That is the matlab wrong, because it is directly proportional to the concentration of the uh, analyte, and absorption is directly proportional to the concentration of species responsible for the color. That is the correct answer. So is that clear? Question number 5. Anyone can reply? Thank you. So question number 6, that during analysis of the deer kidney sample, when SnCl2 and HCl were added, arsenic present in the solution was reduced to. So here that deer death story I wanted to share. So in Kentucky, USA, so why deer are dying? So the why deer are dying? So the analytical chemist went and wanted to analyze what is the region of the death of the white deer. So they find out that herbicide is the responsible for that uh, death of deer. Now they wanted to confirm. So what is the herbicide? So basically this is the disodium sulfur of this CH3ASOOH2. So how they have analyzed that I will discuss, and accordingly that question number 6 to 9 we will solve. So they have taken the kidney tissue of the dead deer and plus herbicide. So that contain the herbicide and tissue. Now tissue is basically your organic substance. So once you heat at the 550 degree for 2 a, which is called dry acing, so what will happen? This organic substance will decompose into carbon dioxide and hydrogen and water, and it will evaporate, right? So now what will happen to the herbicide? Because it's a mineral, so what will happen? Mineral will basically go to their oxides, sulfates, chloride, like that, which are stable at very high temperature. So basically it will form the oxides of the arsenic. So what will happen here? This arsenic 3 plus and 5 plus 2 are the stable oxidation state of arsenic. Now we have the excess of oxygen, so the most stable As2O5 will form. Now the question comes, how to analyze this As2O5? O5. So for this, so what is the method? Basically, we have to dissolve this oxide into the mineral acid, because we know that once we dissolve the oxide of mineral acid in the mineral acid, it will form the corresponding ions. So basically, once we dissolve in the like this As2O5, it will form the H3AsO4. Now the next question is that now we wanted to determine the H3AsO4. So what we have happened? We reduces this H3AsO4 via this mild reducing agent, which is the SnCl2 and NC. So what will happen? This H3AsO4 will reduce to the H3AsO3, and this SnCl2 will oxidize itself, because the property of the reducing agent is that it will reduce the other compound and oxidize itself. Then second thing is that then we further reduce to the H3AsO3 to the arsine gas. So what we have? We have to put the stronger like reducing agent, which is zinc HCl. So what it will do? It will form the AsH3, and zinc will oxidize to ZnCl2, and this will form the water. So this whole reaction will have a special setup, which is shown in the right side. So here we will put the reaction mixture containing this arsenic H3AsO4. We put the SnCl2 and HCl. What will happen? It will form the H3AsO3. Then we put the zinc and HCl. What will happen? This arsine gas will evaporate. For that, we have to put in the solution. Like if anyone has done this, basically this CO2. CO2, which once you hit the calcium carbonate, it will form the calcium oxide and CO2. So basically, we pass through that lime solution, then bubbles will form. Right? We know that experiment. So this bubble will form. Now this arsine gas, if you want to stabilize, we have to use the chelating agent. So basically, your chelating agent is diethyl dithio. This is called carbamate. So AS3H, once it will react with silver dithiocarbonate, it will form a complex. This is the color complex. Now once we have a color complex, it will have a corresponding absorption wavelength called lambda max. So here we use the spectroscopy method, which is UV visible absorption spectroscopy method. So what will happen? This A is, we know that epsilon BC. Now this, once what we do, we will take the known sample, sample of known concentration. We will plot the absorption versus concentration. So we have suppose 1, 2, 3, 4, 5. To draw a line, we need a minimum 5 points. So we take the 5 known concentration R6, 7, and we draw a line absorption versus concentration. Then what we will do, we will we will we will take the unknown sample of this arsine complex, and try to record a UV visual absorption spectroscopy, and we suppose this is like this. So this is your lambda max, and this is the absorption. So now we suppose this is the unknown sample absorbance. Now we can go back to the reverse calculate A is equal to epsilon BC. Now here we know the absorption We know the epsilon molar absorptivity through this line, and B is the solution qubit path length. We know that already, and C. So by reverse calculation we can calculate the C, that concentration of the this complex. Go back to the stoichiometry and we find out what is the arsine gas. Then go back to, we can find out the what is the H3OS O3, and from here we'll go back to, we can find out the H3AsO4, like that. So now come to the question. During the analysis of deer kidney sample, when SnCl2 and HCl were weighted to arsenic present in the solution was reduced to. So we go to the this reaction H3AsO4 after the dry acing and dilute HCl this part. Then we will put SnCl2 and HCl. It will reduce to the H3 H3AsO3. And we can see that also, if you want to solve that in other way, we can find out whether reduction is happening. So here also reduction is happening, here also reduction is happening, here also reduction is happening, here oxidation is happening. That is the first, we can cut it. Now second is question that whether SnCl2 is a strong oxidize reducing agent or mild. So this is mild reducing agent. So it can reduce only one step, not to the second step. So by this way we can cut it, this one, and this is already cut because here this H3OS3 to OS, this reduction will not happen because this is the mild reducing agent. So is it clear? Question number 6. Can anyone tell? Question number 6. Can anyone write in the chat box that question number 6? Oh, that's great. Now, question number 7. In the quantitative analysis of arsenic containing deer kidney sample, H3AsO3 was converted to AsH3 by AD. Now, see, this is the, we want to reduce to this AH3 to S3. So, for this, we need the strong oxidizing, which is ZnNaCl. So, what will happen? This ZnACl. So, I told you that it will form AsH3. Now this zinc will oxidize, it will form ZnCl2, and water molecule will form because they have HCl. So what will happen here? So if you want to balance it, basically go through that ASH3, 3 oxygen, it will form three molecules of water, and this zinc will form zinc chloride. Now here this, to balance the hydrogen we have to put 6 hydrogen we need, so 6 HCl. 6 HCl we can do the balancing by 3 ZnCl2, so 3 zinc we need, like this. So the answer is zinc NaCl. Is it clear that zinc NaCl is the answer for the 7? Question number 7 is clear? Can anyone? Oh, that's great. Question number 8. What is the name of the herbicide found in the deer kidney sample? So here we can see that the CH3 ASOOS2. So now what we here so we can see that directly how many sodium here we can accommodate. So here we have that one proton, like two proton, which can replaced by the sodium. So this disodium salt only can form because sodium arsenide, this is completely like wrong. Monosodium salt, it can't form because it has two proton, so it will form the disodium salt of methane arsenic acid. Tetrasodium is not possible because here there is this methane hydrogen is not, we can't make sodium salt, we can't replace the methane hydrogen by the sodium. So is it okay? Question number 8. Okay. Okay. So can I go to the question number 9? Okay. After carrying out dry acing process in the deer kidney sample, primarily arsenic was converted to. So we know that arsenic herbicide we have, tissue of the kidney we have. So dry acing once we did, what will happen? This organic substance, basically once we heat at very high temperature, what will happen? It will fire the CO2, like thermal decomposition will happen. It will form CO2, water molecule, and so tissue is gone. Now we have arsenic mineral. So what will happen once we do the dry acing? It will form the stable oxide, sulfate, phosphate, or chloride. So here, what is the possibility? We have seen this, like this formula is here, CH3SONA. So basically, it will form the oxide here because there is no phosphorus. Phosphate will not form. Chloride is also not there. So only oxygen is there. It will form the stable oxide. Now we have AS3 plus, AS5 plus. So there are two possibilities. Now we have excess oxygen. So it will form only AS2O5, which is stable. Now, once you wanted to find out what is the oxidation state of AS2O5, so we will let arsenic oxidation state is X. In oxide, what is the oxidation state of oxygen, which is -2. So 2 into X plus 5 into -2, and because it's a neutral compound, is equal to 0, because here there is no charge on that. So 2x is equal to 10 and x is equal to +1. So answer is D, arsenic pentoxide, and its oxidation state is +5. Is it clear? Question number 9. Can anyone tell question number 9 is clear? Can anyone? Okay. Question number 10. During the analysis of nickel sample, electrical properties such as current, potential, resistance, coulomb count by the method. So here, gravimetry method, I told you already that mass of the analyte or compound related to it. We use calorimetry. It's a like measurement of heat of formation and the calorimetry. APX, I already told it's a alpha proton X-ray spectrometry. So only thing is electroanalytical method. So here what we measure? We measure the current I, potential V, resistance R, and coulomb Q. So the answer of 10 is electroanalytical method. Is it clear? I will just come to the now chat box. Okay. So, okay. I will just share it. Now, I just wanted to talk few minutes to all of you. Let me. Okay, sure. I will go back to the slide number 9. Okay, slide number 9. Sure. Okay. Tell me, what is your doubt, Kanchan? Oh, question number 9. Okay, question number 9. Yeah, tell me. Question number 9. Should I explain once again? Oh, okay. 1 minute. 1 minute. I have shared that. Okay, 1 minute. I will share once again. Yeah. Okay. Okay. So, what is the like doubt? Should I explain it once again? Should I explain it once again? This question number 9. Okay. Okay. Fine. Okay. So first of all, that sorry because like I didn't share the slide and I went through the slide. and I forgot completely because once you go to the presentation mode, we can't see the chat box, and this my phone is having issue. It is giving that like sound, like whatever I'm telling, the same thing is coming here. So I just switch up this. So, sorry. And you can give me the feedback whatever like you wanted to improve in this presentation, or you need more topic clearance than the problem solving, or I should do the first concept, I should get it clear and then solve the problem. Like if anyone wants, I can unmute. So let me change the setting. Okay. So anyone want to share, they can unmute yourself and give the feedback, like what you want. Anyone want to give any feedback, like how things should go? So I will upload this on my YouTube channel. I will share that link to that in the chat box. You can go after that. So anyone want to give any feedback, like what need to be done, something like that? Okay, so should I close the meeting if anyone don't have any issue? Hello. Sure, sure. I will send the PPT link to you, and next time I will try to improve even better that PPT this time, because this is first time. So I have made the PPT. Next time I will include more of the more like uh, this explanation will be there. Then I will go to the question and answer. So sure, I will send you the PPT link to you guys. Definitely. Okay. So now I am signing out, and thank you for all joining. See you in the next Tuesday. So then next Tuesday, I think there will be no issue regarding this screen sharing and all. Okay. Okay. Thank you. I will sign it now. If anyone has any question, they can ask. Sure. Okay.